Good morning. I see that you had an HIV test and the results show that you have the antibodies for HIV. Let me start off by explaining what HIV is and what we are dealing with. Human immunodeficiency virus, or HIV, is a lentivirus in the Retroviridae family. It has a single-stranded RNA genome and is the causative agent of acquired immunodeficiency virus, or AIDS. What made you decide to get tested for HIV?
I felt like I had the flu. I had a fever and swollen lymph nodes, and I felt very fatigued. I went to the doctors to get a flu test, but it came back negative, so they suggested to get a HIV antibody test as well. After I had mentioned, I had sex with someone a few months ago who later found out that they were HIV positive.
It sounds like you are in the acute infection phase right now. Currently, your immune system is starting to pathogen sense with pathogen-associated molecular patterns, or PAMP, a viral RNA bound by pathogen recognition receptors, or RIG-1-like receptors, and the cytosol of CD4 T cells, or in the endosomal membrane from toll-like receptors. Once this occurs, type 1 and type 3 interferon pro-inflammatory cytokines and chemokines are activated. Recruit innate immune cells, including natural killer cells, dendritic cells, and macrophages.
So, if I have the innate immune cells, why didn't they stop the virus?
Unfortunately, the macrophages can be infected by the virus, which limits their ability to present antigen to T cells, phagocytose, and signal to recruit more immune cells like natural killer cells or neutrophils. If natural killer cells cannot be recruited to the infected cell, then they cannot kill the virally infected cells or make macrophages better killers. As for the dendritic cells, they will collect the antigens with their cytoplasmic extensions and present the peptide to the T cells in the lymph nodes, but the virus can end up infecting the T cells.
I've heard that the HIV virus targets T cells. How does that work?
A major histone compatibility complex class II molecule will display an antigen for TCR and its co-receptor CD4 to bind to on the MHC class II molecule. HIV will then infect the cell through its envelope glycoproteins GP120 that bind to a receptor on the CD4 T cell and to chemokine receptors CXCR4 and CCR5. Since the HIV virion binds to a CD4 receptor, the helper T cells are greatly affected because they are infected by the virus and can't perform their functions of cytokine secretion to activate macrophages, inflammation, and further differentiate into subtypes. Afterwards, there is a fusion of HIV and the host membrane, allowing entry of the viral genome into the cytoplasm. HIV utilizes reverse transcription to translate the genome from single-stranded RNA to single-stranded DNA to double-stranded DNA. It is highly error-prone and has no proofreading mechanism. Therefore, mutations accumulate. Next, there is integration of the provirus into the cell genome and cytokine activation, transcription of HIV genome, and transport of RNA into cytoplasm. Once the RNA is in the cytoplasm, there is synthesis of HIV proteins and assembly of virion core structure that expresses GP120 and GP41, which make up the envelope spike complex on the cell surface. The spike complex is what allows for HIV attachment, fusion, and infection of the host cell. After the expression of GP120 and GP41, the mature virions are budding off. Virus particles are now free to move to other cells and infect them, which leads to the depletion of T cells circulating and T memory cells, since they are located in the blood and lymphoid tissue that the virion has access to.
I remember learning in my immunology class in college that there's also CD8 T cells. Why aren't they helping?
CD8 T cells kill infected cells by antigen recognition and binding of cytotoxic T lymphocytes to the target cell. This causes cytotoxic T lymphocyte to activate and granule exocytose, where perforin helps granzyme get into the target cell and granzyme activates apoptosis. HIV inhibits the expression of MHC class I molecules and CD8 T cells are defective because cytotoxic T lymphocyte requires CD4 T cells to send cytokine interferon gamma to help activate the CD8 T cell, and with low amounts of CD4 T cell, it increases susceptibility to viral infections.
So, Dr. Z, how are CD8 T cells activated by the CD4 T cells?
When ingested by dendritic cells, the antigen-presenting cells may present viral antigens to MHC class I and MHC class II molecules, so that the CD8 T cells and CD4 T cells specific for viral antigens are near each other. CD4 T cells can activate CD8 T cells to promote its function of antiviral immunity and survival of the T cell.
What about my antibodies? Isn't that what I just got tested for? Shouldn't I have some?
It can take up to 6 months for HIV antibodies to be produced in response to exposure of the infection. Also, it takes time for the virus to replicate enough for a test to detect it from the antibodies produced as a response of the infection. However, one of the signals needed to activate B cells to create antibodies is T cell mediated activation. With a low number of T cells, it is difficult to activate a B cell with the HIV antigen. Without antibodies, they cannot neutralize the virus by causing the loss of the virus's ability to be infectious through many immunoglobulin molecules binding to the surface of the virus, preventing entrance into a host cell and decreasing its ability to replicate. Also, antibodies will no longer be able to phagocytose or mount antibody-dependent cellular cytotoxicity.
Oh, wow. That's some pretty interesting information. So, Dr. Dunzik, what happens next?
The second stage of the HIV infection is known as clinical latency, and HIV is active but reproduces at lower levels, and that is why some individuals do not have symptoms during this phase. Then the final stage is known as AIDS, and the infected individual is immunocompromised and generally can die from opportunistic infections. In this state, CD4 T cells are below 200 cells per cubic millimeter. The normal range of CD4 T cells is 500 to 1600 cells per cubic millimeter. There is some good news, though. There are some great antiretroviral drugs on the market that can give you a lifespan of decades. The one I recommend is highly active antiretroviral therapy, or HAART, because it uses multiple drugs and interferes with the HIV life cycle to prevent viral replication.
That's some really tough news to hear, but I'm glad there's a treatment out there for me.